In this screencast I'll show you how to use the shortcut distillation column. So over on the PFD palette, click on columns and then you click on the shortcut unit operation and then you place that onto the flow sheet by clicking, and you have to specify whether you want a condenser and whether or not you want a reboiler. So we'll have both of those for this example, and we'll just resize this so it fits a little bit better onto the flow sheet. Then we have to connect up an input stream and some output streams for the top product and an output stream for the bottom product. Okay, for the input we need to enter some data. So we'll supply a total fluid flow rate of 800 kmols per hour with 50% methanol and 50% water, and we'll specify this as being at atmospheric pressure, and we'll say that this is at its bubble point, so it's at a temperature where it's ready to produce vapor. Click OK. Now we need to supply some process conditions for the column, so we click data entry. On the specifications button we need to select two specifications where we define a parameter and enter a value for it. So for the first specification I'm going to select stream S2, that's the top product, and the parameter that I'm going to select here is the composition, and I'm going to select this for methanol. So click OK, and at the moment it says this will be in a mole fraction. We'll just change this to mole percent and click OK, and I'm going to specify this value as being 95, so we'll have 95 mole percent methanol in the top product. Then for stream S3, the bottom product, I'm going to specify that the flow rate of the methanol will be 2% of that which is in the feed. Okay, so the value then, we had 800 kmols per hour feed and 50% of that was methanol. So we have got 400 kmols per hour of methanol coming in. 2% of that will be 8 kmols per hour. Click OK. The specifications button has now gone blue. So all that remains for us to do is to click on products, and what is required here is an estimate of the flow rate in stream S2. So we'll put in 400 kmols per hour, since that is half of the feed rate and should provide a reasonable estimate of the flow rate in stream S2. And we click OK, and everything is now ready to run. So we press the run button, and this is now very quickly solved the simulation, and we can review the data. So in stream S2 we can see the temperature and pressure. If we click on material balance from this drop down menu, we can see that the methanol mole fraction is 0.95, as we'd expect, since we said that this should be 95 mole percent methanol. And if we click on stream S3 and look at the data review window, we can see some additional information here as well about the bottom product stream. So we can see that the methanol mole fraction is 0.021 and the H2O mole fraction is 0.979. We also have the flow rate, the pressure, the temperature of this stream. We can also click on the view results, molar results, and if we scroll down in this window, we can see that the methanol flow rate is 8 kmols per hour, and again that is something that we specified for the problem for the simulation to use. We can also click on the review window for the distillation column, and the information provided here is the Fenske index, and this is the number of trays or equilibrium stages required to achieve the separation under total reflux. So that is the minimum number of equilibrium stages required to solve the problem. Okay, so overall that is a first look at using the shortcut distillation column in Pro 2.